Welcome back. In this lecture, we'll cover fair value using net present value, and this is module 6, which is on value measurement via discounted cash flow analysis. Analysts who analyze firms' equity often use discounted cash flow analysis to find out the true value of the equity or to decide whether they should invest in a particular share or not. In the meantime, chief financial officers who analyze investment projects also use discounted cash flow analysis to identify whether the investment or project is accepted or rejected. There is no fundamental difference between the analyst who analyze firms' equity using discounted cash flow and the analyst who analyze investment projects using discounted cash flow, because both analysts assess whether the present value of future cash flows of the firm or project is worth the initial investment today. In case of equity investment, the initial investment could be the current share price. In case of capital project, the initial investment could be the investment which will be made today or at the beginning of the project. Let's look at net present value. By the term, net present value means present value of benefits minus present value of cost. So here is a formula of net present value. So the first part over here indicates the present value of benefit minus the second part, which is I0, indicates present value of the initial investment. As per net present value, we'll accept a project if the NPV is positive, because if NPV is positive, it will increase shareholder wealth. And based on NPV, we'll reject the project if the NPV is negative, because if we accept a project with negative NPV, it will reduce shareholder wealth. Let's look at an example of NPV. So over here, this project has a lifespan of 3 years. In the first year, it will generate 50 million cash flow. In the second year, it will generate 50 million cash flow, and in the third year, it will generate 100 million cash flow. And the project will require an initial investment of 150 million today. So the reasonable discount rate of this project is 5%. Based on these information, NPV of this project is $29.35 million. So the year 1 cash flow of this project is 50 million divided by 1.05. 05 means the 5%, which is the discount rate to the power 1, as it is in year 1. So the present value of 50 million, which will be generated in year 1, is 47.62 million. Similarly, present value of 50 million cash inflow, which will be generated in year 2, is 45.35 million. And in the final year, the project will generate 100 million cash flow, and its present value is 86.38, and its initial investment is 150 million. As there is no other investment in this project, there is only initial investment, so the present value of the cost is 150 million. And based on this, the net present value of this project is 29.35 million. As the NPV of this project is positive, project is accepted, and this project will add value to the shareholders' wealth. Now, if the project is risky, we might need to increase the discount rate. So risks and the uncertainty with the cash flows might also decrease the value of the project. If the CFOs, that is the Chief Financial Officer, decide to increase the discount rate of the same project to 20%, In that case, NPV of this project will be minus 15.74. So the NPV of this project is negative if discount rate is 20%. In this case, the project should be rejected as the NPV is negative and this project will decrease the value of shareholders. So therefore, we should not accept this project with 20% discount rate. Now that's all about this lecture. In our next lecture, we'll cover caution when using discounted cash flow analysis.